This is Chandana. The topic is about internal characteristics of a shunt generator. This self-excited DC shunt generator. Internal characteristics of a self-excited DC shunt generator. In this self-excited DC shunt generator, we can find internal characteristics by external characteristics. Internal characteristics can be obtained from external characteristics. That is by adding armature resistance drop to the internal characteristics to the terminal voltage. That is, see here, internal characteristics are obtained from external characteristics. That is by adding armature drop, that is IA armature resistance drop to the terminal voltage when the load current is treated as OA and the armature resistance drop is treated as AB, and let us assume terminal voltage is AC. Let us draw a figure. Let us draw first external characteristics, that is the curve. From this we can obtain internal characteristics from this external characteristics curve. As we know that to get a point on internal characteristic, the armature resistance drop is added to the terminal voltage. So we should add the terminal voltage here AB, that is, this is A and this is B. So here AC is the terminal voltage. This is point A. To get point D here. So from this we can draw easily internal characteristics from this external characteristics curve. As we know that to get a point on internal characteristic, the armature resistance drop is added to the terminal voltage. So we should add the terminal voltage here AB, that is, this is A and this is B. So here AC is the terminal voltage. This is point A. To get point D here. So from this we can draw easily internal characteristics from this external characteristics curve. So it is represented with dotted one. So here is AC is the terminal voltage, AB is the armature resistance drop, and this is the IA or A drop, that is armature resistance drop, and here XS is to consider as field current. That is IF, and on y-axis we consider as generated EMF, which is denoted with capital E. This is point started with O. This is the R, and this dotted curve represents the internal characteristics which obtained from external characteristics. So similarly, by adding different types of armature resistance drops for the various points of external, this is the external curve. So in this way we can add different types of armature resistance drops for the various points of Here also we can add. So will get this internal characteristics from the external characteristic of carva. So in this way we can add different armature resistance drops for the various points of external characteristics. So in this way we can obtain internal characteristics. So in this figure we can see the internal characteristic curve. This is the internal characteristics curve. So finally we can conclude that internal characteristics can obtain from external characteristics by adding armature drop, armature resistor, that is IRM, to the terminal voltage. This is the terminal voltage, that is AC, to get point D. Thank you.